Hello and welcome to PB-Spec, the channel about vibrational spectroscopy. Today I'm talking about what is vibrational spectroscopy. Spectroscopy is the interaction of light with matter. A typical spectroscopic experiment consists of a source for electromagnetic radiation, the sample or specimen, and a detector, which collects radiation from the sample and transforms it into something visible for us, the spectrum. Vibrational spectroscopy probes molecular vibrations. This is certain movements of the atoms relative to each other. The most important thing to understand is that in vibrational spectroscopy there are two separate topics. One is molecular vibrations, the other one is energy transfer. Molecular vibrations are displacements of the atoms relative to each other, not changing the center of mass of the molecule. These displacements follow certain patterns and symmetry considerations play an important role in describing them. The collective displacement of nuclei at a certain frequency is called a vibrational mode. The number and character of vibrational modes is a molecular property. Therefore, it is unaffected by the spectroscopic method being used. This means that molecules can vibrate in certain ways and will do so regardless of us observing them or not. The energy transfer, on the other hand, is the method being used to study molecular vibrations. It describes the excitation of a vibrational mode, in many cases from a ground state to a higher vibrational state, that means to higher energy. The energy for this change was transferred from the incoming energy, that is the electromagnetic radiation we directed onto the molecule in our experiment. Depending on the experimental setup, we might measure the loss of energy, that is the difference in input versus output, or other new forms of energy. That could be, for example, emission at a different wavelength than the incident one. Depending on the type of energy transfer, we might not see all vibrational modes of a molecule. Therefore, spectra of different vibrational spectroscopies do not look the same. Attention, this is a key concept. The separation of vibrational spectroscopy into these two topics is something many people have problems with. Understand that molecular vibrations and energy transfer are two separate things to study, to really make sense of vibrational spectroscopy. To put it simple, molecular vibrations is what the molecules do and depend not on the method, whereas energy transfer distinguishes one method from the other and is characteristic for each of the methods. In one sentence, molecules vibrate regardless of the method being used. Different methods just see different vibrations. Common methods to probe molecular vibrations are infrared spectroscopy, often seen as FTIR, Raman spectroscopy, inelastic electron tunneling spectroscopy, in short IETS, and inelastic neutron scattering spectroscopy, short INS. For a brief overview how they work, let's start with infrared spectroscopy. Here we have our molecule and it requires a certain amount of energy to perform a specific vibration. This energy happens to be in the infrared range, and if a photon with exactly this energy arrives at the molecule, the photon is absorbed and its energy transferred to the molecular vibration. The energy transfer mechanism for infrared spectroscopy is absorption. In Raman spectroscopy, we have a different process. The arriving photon has more energy than is required for our vibration. In classical physics, there is no matching of the energies, and therefore no interaction will take place. However, in quantum physics, there is a small chance that both will interact. In such a case, the incoming photon bounces off the molecule, transferring exactly the energy required for the vibration. The scattered photon leaves with less energy. This is called inelastic scattering and is the energy transfer mechanism of Raman spectroscopy. Inelastic electron tunneling spectroscopy works the same way. The difference is that instead of a photon, an electron is bounced off our molecule, again transferring some of its energy to excite the molecular vibration. The energy transfer mechanism is also inelastic scattering. Lastly, the same goes for inelastic neutron scattering spectroscopy. Here, instead of photons or electrons, neutrons are scattered, exciting molecular vibrations. The energy transfer mechanism again is inelastic scattering. In summary, we can say that in spectroscopy, energy is transferred to the molecular system. What is interesting for us is the difference between input and output. From this difference, we deduce energies and therefore properties of the studied system. The energy transfer depends on the method. This means that also the spectra differ, and clever spectroscopists use this to their advantage. This was PBSpec, the channel for vibrational spectroscopy. Thanks for watching.